Alright, we are going to do an example of Hess's law. So let me first give you the equation we're trying to find the delta H for. So 3 carbons plus 4 H2 gas, and these phases are really important. Okay, you can't leave phases off on Hess's law. It gives us C3H8 gas, and we want to know the delta H for this process. So we are given some equations. The first equation you're given is C3H8 gas plus 5O2 gas plus 3CO2 gas plus 4H2O liquid. Alright, now I'm going to give delta H's up here in kilojoules. I just don't want to have to keep writing that over and over again, so I'm just going to give the value here. This is negative 2220. Next equation, C solid plus O2 gas gives us CO2 gas. And that has a value of negative 394. And finally, we are given H2 gas plus 1/2 O2 gas, and that yields H2O liquid, and that has a value of negative 286. Okay, and of course those are all kilojoules. So what we need to do is take those 3 equations below and flip them around, multiply them, manipulate them some way so they give us this equation up here. That's the goal. Take these guys and get that up above. Okay, let's just erase this because I'm going to be writing more. Hey. Yeah, there we go. Okay, so what I'm going to do, just kind of I'm going to draw a jagged line here just to separate the top from the bottom, because I'm going to end up rewriting all of those equations down below. So let's start with this yellow equation, or orange, whatever color that is. I'm going to look at the orange equation, this equation here, and the top equation. I'm going to see what they have in common. Okay, the first thing that pops out, C3H8, C3H8. But notice they're on opposite sides of the arrow. That's okay, because what I can do is I can rewrite this equation. What I'm going to do, I'm going to write myself some instructions here. I'm going to flip this whole thing, okay? And you'll see what I mean by that in a second. And when you flip a reaction, that means you have to change the sign on delta H. So if you flip a reaction, you got to change the sign. So let's do that. So I'm going to write the products as reactants, reactants as products. 3CO2 gas plus 4H2O liquid gives us C3H8 gas plus 5O2 gas. And when I say I flip the sign, 2220. Okay, still kilojoules. So that's good. Let's move on to the purple reaction. All right. So again, inspect the reaction, see what it has in common with the one up above. There we go, C solid and C solid. But notice this is a 3 up here and we only have a 1 there. So what I'm going to do to this reaction is I'm going to multiply everything by 3. And that includes the value for delta H. So I get 3C solid plus 3O2 gas gives me 3CO2 solid. Gas. And the value for delta H, it's Negative 394 times 3, that works out to be negative 1182 kilojoules. All right. Now let's look at that blue reaction. Let's look at this one here. And again, just inspecting the reaction, I see H2 there, and I see H2 there. Both reactants, but the one on top is times 4. The one down here is times 1, so just got to multiply this one by 4. And again, multiply delta H by 4 as well. So what we get is 4H2 gas plus 2O2 gas gives us 4H2O liquid, and 4 times negative 286 is negative 1144 kilojoules. Okay, now what I'm going to do is add these all up. And you can add them all up, and you can write all those reactants down, and then you can write all the products down and cancel it. I just like to save myself a step. And here's the way I like to do it. I look and I see, I'm going to go through this reaction. Actually, it's kind of handy to have the reaction up on top. Let's shrink this a little bit. Okay, so look at the black reaction up on top and the 3 on the bottom. So I see 3CO2 gas here as a reactant, and here it's as a product. Okay, I can cancel those out. 4H2O as a reactant. Okay, 4H2O as a reactant. Oh, down here, 4H2O as a product. Cancel those out. Okay, opposite sides of the arrow, they cancel. C3H8. Do I want to cancel that? No. I circle that because it's up here in the original reaction. 5H2O. Well, here's 3H2O and here's 2H2O. So I can cancel those together with that. 3C. Well, that's in the original equation up here. 4H2. That's in the original equation up here. So now all I have to do is write down everything that's left and then add up my values. So I get 3C solid plus 4H2 gas gives me C3H8 gas, and then the delta H. Delta H is equal to 2220 plus negative 1182 plus negative 1144, again, all kilojoules, and that works out to be a value of negative 106 kilojoules. So given those 3 equations, we are able to calculate the delta H for our original equation, which I'm sure you are all dying to do. Anyway, that's a Hess's law problem.